So this next little section, I'm going to show you how to square a binomial. Very similar to what you just did, however, these binomials, as you can see from that worksheet, have a square root in them. So just a little bit of a little trick there. Again, it's still a binomial, you're still squaring it. The only difference is that these two, which you're about to see, contain a radical in them. Okay? This is the basis for what you guys are going to be doing when you solve the radical equations. So again, follow along, take notes underneath each example. This is a good resource for you. Just pay attention. If you have to rewind, you can do that. It's not that hard, it's not that tricky, it's just being very meticulous with your work. Okay, so I'm going to show you how to square this binomial. As you can see on that worksheet, it is the quantity, the square root of x plus 2. This whole quantity right here is being squared. So once again, I'm going to play it safe, and I am going to just pay attention to that squared exponent, and I'm just going to say, okay, since it's being squared, I'm just going to write that binomial twice. So that's going to tell me that I have a root x plus 2 multiplying with another root x plus 2. And now that I'm set up, now I'm going to FOIL this. Okay. Now, the beginning part is a little scary, but it's not something that you're not capable of learning or seeing or following or getting. Just take it step by step. So I'm going to show all my work. So I've got a root x multiplying with a root x. That's the first thing in my FOIL multiplication. When I multiply this root x with this root x, because they're both underneath a radical, I'm going to keep them underneath a radical. So in other words, when I go with root x times root x, I'm going to keep my radical, and then since it's a root x times a root x, those exponents add. So it's going to be the square root of x squared, which I'm going to deal with in a minute. My next multiplication, my next part of the FOIL, remember, is now to take this root x and multiply it with this 2. Root x multiplying with 2. Because this x is underneath the radical and the 2 on the end is outside, I cannot multiply those two things together. So, therefore, what happens when I do this multiplication of root x times the positive 2, that 2 stays outside. The x is inside the radical, the 2 is an outsider. What's outside and what's inside never mix when you multiply things with radicals. So what that's going to give me is that's then going to give me a 2 root x for my outer multiplication. My inner multiplication, you're going to see, is going to be very similar. It's going to be 2 times that same root x, which is going to give me another 2 root x. Okay, again, this 2 that's outside cannot multiply in with that x. The 2 is an outsider, the x is an insider. Outside times outside, inside times inside. That's how multiplying radicals works. But when you're multiplying like this, that 2 has to remain outside. And then the last easy multiplication is the 2 times the 2, which is a positive 4. So, what we've got then is we can just kind of work our way through this problem. Anything that we can combine is right here. We've got a 2 root x and another 2 root x. So if I have 2 root x and 2 root x, I can add those up because they are like radicals. It's a root x with a root x. I can just add those up. That becomes a 4 root x. This 4 on the end stays as a plus 4 on the end. But now I have to deal with this guy right here. Okay? Now, here's the magic that happens when you have the square root of something squared. When you have the square root of something squared, what happens is the square root kills that squared term. Okay? So these things will cancel, and that just leaves me with an x at the beginning. So this is my simplified version of expanding that binomial, x plus 4 root x plus 4. That's what I get. Okay, the radical goes away at the beginning. Okay, so right here, there's no radical because the square roots canceled out. The middle term contains a radical, and then the number on the end is just the number on the end of multiplying that 2 with the other 2. Okay, so that's how the first one gets multiplied out. Now here's the second one. I have, again, the quantity root m, this time minus 12, getting squared. So here's my radical, here's my binomial, the two terms, and this binomial is being, once again, squared. So I, again, am just going to play this safe. I'm just going to say that it is just root m minus 12 multiplying with another root m minus 12. I'm just going to repeat the same process I just did with the other one. Okay, step by step, just work your way through it. So the root m times the root m, again, that's going to be the square root of m squared. If you're quick and you want to just call that m right away, that's fine. I'm just showing you this to emphasize the fact that when you multiply underneath, you can do this because they are both underneath and the exponents add. Now that root m multiplies on the end with this negative 12. So I have negative 12 root m. My inner term is another negative 12 root m. And my last multiplication is going to be a positive because, as you already know, a negative times a negative is always a positive. 144. Now we just look to condense. We'll always be able to condense in the middle with the negative 12 root m and the other negative 12 root m. There's going to be negative 24 root m for my middle term. The 144 isn't doing anything, so it just stays on the end as 144. And again, this is the weird thing right here. You're square rooting something squared. You already have a pair of m's underneath the square root. So they will cancel the square root and the squared, leaving you with an m at the beginning. So our binomial, root m minus 12 squared, this guy at the very top, wrote it twice, foiled it out, double distributed, however you want to call it, and gave me this answer right here. M minus 24 root m plus 144. That's how that binomial gets expanded out.